In our solar system, there is only one such planet where life of any kind has been found so far. Now you can call it a coincidence or something else, but this life is not here because of any specific miracle. When the Earth is rotating on its axis, day and night are formed, and when the Earth revolves around the Sun, seasons are created. When this rotation completes, 360 degrees one day is completed, and in a year, our Earth travels a distance of 1 billion kilometers. Our Sun does not revolve around the four directions, nor does it matter where you are on Earth. We all, along with this, in this universe, these immense amounts of speed are constantly traveling. If I tell you next that you are traveling in space at a speed of 186 miles per second, you might not believe it, and that's why in today's video, we are going to understand this speed. Obviously, this speed and motion are quite complicated, so we will have to look at the galaxy and even beyond that, go out into space. So today, you and I are going to learn a lot of interesting things about the universe. So let's find out how fast you are actually traveling in space. We know that gravity keeps our sun, planets, asteroids, comets, and other objects in orbit. Then this entire solar system, along with our galaxy's central black hole, is also orbiting, and it keeps getting bigger than this. But our Milky Way, along with its local group, is traveling in the intergalactic space. So by combining all these things, we will calculate a final cosmic motion. But one thing to remember is that motion is always relative. That is, it depends on with respect to whom we are finding the motion and speed of something. Like if two passengers are sitting in a train, they are not in motion with respect to each other, but someone who is standing outside the moving train, for them, both those passengers are in motion. This means that speed and motion are relative quantities. So first of all, let's start with the spinning speed of the Earth, that is, how fast the Earth spins on its own axis. Here, you might find this a little difficult to understand at first, but this whole thing is very simple. Depending on where you are on Earth, the speed at which you are spinning will change. We believe that our Earth is a rigid body whose shape does not change. Because of this motion, it completes one rotation on its axis in 24 hours. To be more precise, this time is 23 hours, 56 minutes and 4.09 seconds. The average radius of the Earth is 230 miles, but this is just the surface average. In reality, the Earth's structure contains rocks, gases, and a lot of other things. But because of this rotation, there is also a very big bulge at the equator. So if we talk about the precise radius, then it is maximum at the equator. The distance from Earth's center to the equator is 6,238 miles, while to the North Pole it's only 6,221 miles. That's why it is said that the Earth is slightly flattened at the poles, and because of this, the distance is maximum at the equator. If you look at the speed at the equator, it is about 1,041 miles per hour, and as we move towards the poles, this speed will decrease. For example, at 45 degrees latitude, this speed will be around 735 miles per hour. And as we reach the poles, this speed becomes zero. That means at the geographical poles of the Earth, it only rotates completely, it doesn't travel any distance. So the speed of the Earth depends on our position on the Earth. Like maximum speed is at the equator and minimum speed is at the poles. Now let's talk about how fast the Earth moves around the Sun. So first let's consider the rotation speed of the Earth, 1041 miles h, which translates to 0.29 miles s. But the speed at which the Earth revolves around the Sun is not less than this speed either. The Earth orbits the Sun at a distance of about 15 crore kilometers, and to remain stable in this orbit, the Earth has to travel at a speed of 18.64 miles per second, but our Earth travels around the Sun at different speeds throughout the year. When the Earth is closest to the Sun, it moves at its fastest speed, about 30 to 18 miles per second. And when it is farthest from the Sun, its speed decreases by about 3%, and at this speed of 18 miles per second, it completes its orbit around the Sun. That's why everyone's speed is different in this system, and the closest planet to the Sun completes its orbit at a speed of 29.2 miles per second. But for the next planet, this speed is not enough to complete its orbit. So now let's talk about how fast our entire solar system is traveling around the center of the Milky Way galaxy. As we know, the faster something moves, the more energy it needs to maintain its position, and it will need to orbit at a higher speed to stay in position. The same thing happens in the case of a galaxy as well. Here, there are stars that are moving away from the center of the galaxy and going farther out. Similarly, our Sun is also present at a distance of about 27,000 light-years from the galactic center. This distance is so great that the Sun is far away from this galactic center. It takes about 220 to 250 million years to complete one orbit. This means that when the dinosaurs were last seen on Earth, the Sun was in a completely different position in the Milky Way. This also means that our Sun is traveling around the Milky Way at a speed of about 136 miles per second. The Earth's speed is about 7 times greater than that, but here there is a lot of uncertainty, which means our solar system could be moving even faster. And then Milky Way is a galaxy. We can't exactly trace the motion of these objects because there is always something moving here. And after this, if we leave the solar system and talk about the galaxy, this uncertainty increases even more. Apart from this, the plane of our solar system is inclined at about 60 degrees to the plane of the galaxy. And because of this, the speed of our Earth also keeps changing a lot. Because of this rotation of the solar system, the speed of the Earth keeps changing. When the Earth moves in the direction of the movement of the solar system, its speed increases and can reach up to 147 miles per second. And when it moves in the opposite direction, it remains at about 129.2 miles per second. So from this, we can see the effect of orientation on the speed of our Earth. And because of the motion of the solar system, the maximum speed of our Earth can go up to 147 miles per second. So now let's talk about our own galaxy, the Milky Way, which is also traveling within its own local group. Gravitational force works in such a way that the more massive two bodies are, the stronger their gravitational attraction will be. And this massive influence also helps us achieve insane speeds on cosmic scales. In our local group, there are about 60 galaxies in total, among which the Andromeda galaxy is the largest and is at the second number. The Milky Way and Andromeda galaxy, separated by 2.5 million light-years, are rapidly approaching each other. Because of this huge distance and size, it's really amazing. It becomes very difficult to know exactly how these two galaxies change their position over time, so that we can find out its speed, because even here, things can go beyond the human time scale. But even then, there is hardly any blue shift seen on the spectral lines. By studying it, what we have observed is that Andromeda is coming towards our Sun at a speed of about 187 miles per second. And when we looked in our direction in the Milky Way, considering that factor, Andromeda is moving towards our galaxy at an average speed of about 67 miles per second. And now we will see how our local group is traveling in intergalactic space. Finally, on this grand scale, things can seem quite weird. Here, galaxy groups, clusters, superclusters, and even groups of superclusters are shaping the universe. The areas of space that are very dense pull everything around them with their massive gravity, and the areas that are empty, or the voids, they repel our local group. In a way, the entire supercluster is pulling us and our massive gravity together. So those distant and the voids in space, they are pushing us away from the Virgo cluster, and this speed is truly insane. If we are moving at a speed of 186 miles SES, then at the same speed of 186 miles SES, the voids are repelling us step by step. Because of this, our local group is getting a combined gigantic speed of 372 miles SES. So if we summarize, our total speed is being formed by combining these components: the Sun's motion around the Earth, the Sun orbiting the galaxy, the Milky Way's movement towards Andromeda, and finally the movement of the local group. To understand the reasons for this, we have covered a very large scale here. But if we talk about a particular direction, then our total motion is the result of the combination of all these. So, we are currently traveling at a speed of about 390 miles per second with respect to the background of the galaxy. One more clear thing, what we find here is that motion is relative. If we want to measure our speed, we also need to know that this speed has to be measured with respect to something. In this universe, our frame of reference constantly changes and nothing remains static. Here, from the smallest atom to the largest scale, everything is constantly moving. But our limits are only up to here, and no one knows how big this universe actually is. And in all this, what is our reality? And is this reality even true or not? What do you think? Should we continue this journey in less time? If you like this video, then definitely share it with your friends. Also, for more such videos, subscribe to our channel and make sure to enable the bell notification. We will meet you soon with another informative video like this.